This is Scott from KIG. It is October 13th, 2020. We're going to do a runoff video or videos of this 3 horsepower glycol system intended for and set up for a brewery. In this case here, this is one of our 3 horsepower Heatseeker modules is what we call that. And this is kind of interesting in that it's a condenser compressor arrangement, but actually inside here is where we actually have a plate heat exchanger, a flow switch, a adjustable refrigerant pressure switch, and so forth. And then down below here is we have the inlet and outlet connections, which are 1 inch to go out to your process or processes. And the idea is this is a very economical setup, an extremely economical setup if a customer wants to do the pump and a remote glycol tank on their own. In this case, we did it for our customer. This is an approximately 35-gallon glycol reservoir, insulated on the sides and on the bottom. It does not need to be insulated on the top if it's just a lid, because it's not in contact with the glycol, FYI. We have a nice 1 horsepower centrifugal pump here, and we have a shut-off valve that should remain open at all times when running. That's strictly just for service. So what we would do, or what the customer's going to do, is probably mount the condenser assembly outside, and this is the controller and electrical assembly. We have the covers for that. This is the output, 1 inch NPT. This is going to be the supply line that goes out to your tank or tanks. In our test environment, and this is ours, part of the test, the chiller ships with the output line here. In the test environment, we just have it going back to the tank. That here is going to be your return back to the tank, okay? The pump draws from the bottom of the tank, and that's heavily insulated. And then this is the discharge, which is 1 inch, okay? This is going to ship just with an opening here. You're gonna pipe it 1 inch from the discharge back into the chiller. Included though is this T. This T, the inlet to the chiller, which has a well on it, that is where we're actually sensing the temperature. Okay, so this inlet coming back to the chiller will have this T, and this is where your temperature probe is. The control system is sensing that temperature here. So one of the most important things about this arrangement is, unlike some other packaged chillers that we sell, is we need to talk about a bypass. So this is going to go out to your tank or tanks. Presumably all your tank or tanks, your jacketed tanks, are going to have a controller and solenoid valve on them. When none of your tanks are calling for cooling, meaning all those solenoids are closed, we need some way in your piping to have some glycol come back to the chiller. In this case here, because there's an internal flow switch, the best is to use a spring-loaded bypass valve, so that when all your solenoids are closed, that is when the bypass valve opens and brings some glycol back to the chiller. But when you do have your tanks calling for cooling, we're using all the flow to go through the tanks, and that bypass valve will be closed. And just call us if you want us to explain that to you in more detail. The chiller is wired for 208, 230 volt single phase power. In our test environment here, we actually just wired it right back to the main power in here. You can do that too. If you do, just make note of the amp ratings on the pump, which is like 7 amps and change when it is running. Let's double check that is the case. Yeah, so the 14.8 amps, that's if it was set up for 115. This will go about 7.4 amps at its 208, 230 single phase. Very important that you have an amp meter while you're dialing in the system to make sure that when all your tanks are calling for cooling, which is the worst scenario, it's going to be pumping the most, that the pump is not over amping. That's the biggest startup issue. Pump likes to see some back pressure. So it's common that you dial back on valves or shutoffs going into each one of your tanks, that you throttle those down so that we're not overamping the pump. We have a startup guide that we can email you, although for a different configuration chiller, it applies on how to dial the system in, particularly for dialing in the pump amps. So you just bring your main power here in the outdoor section. Right, it says power in. It's pretty simple because it's single phase power. You got a red, a black. This is just our power cord. It's just capped off, and then your ground. The simple Ranco controller. What you want to do is you always want to get away with the highest differential that you can. I'd like to see you start out with 4 or 5 degrees. 2 degrees is probably too tight. That'll induce short cycling with the chiller. I'm going to take this off. This is just a side cover, but it is our model BP GC36. 36 stands for 36,000 BTUs or 3 tons of cooling nominal. 2019 single phase unit. So you just go up to the Ranco controller here. I have it set up at 57 right now. Just going to press set. It lights up. Get a good angle here. Set again. Fahrenheit. Set again. That's my set point. We're going to bring it down for the test run. Let's bring it down to 28. 28 glycol. Set again. 4. That's our differential. Set again. Cooling mode 1. Leave it there. Set again. It should start. Okay. So then just recycled back. 57 is what the current temperature reading is. So our chiller compressor just turned on. It's single phase, so we don't have to worry about the phase. Really not that loud. The compressor is running now. Fan is running now. I'll come back to video number 2 once we reach the set point of 28, and then maybe I'll do a quick one, video number 3, after it runs for a while, showing some frost built up.